Hello everyone, in this video I'm gonna explain quadratic inequalities. Actually, they're not different from quadratic equations. As you know, quadratic equations are defined as ax squared plus bx plus c equal to 0. A is different from 0, you know this one. And what about quadratic inequalities? We just change equal to symbol with greater than symbol as you see, or we can use another inequality symbols like this. So a quadratic inequality must have x squared and inequality symbol as you see. Okay, let's check the question. For example, which of the following expressions are quadratic inequalities? Okay, let's check the first one. The first one, okay, now at first let's check the coefficients of x squared and x. And here coefficients of x squared and x are real numbers, it's okay. And we have x squared and we have here inequality symbol. So this one is an inequality, a quadratic inequality. What about the second one? Second one is also an inequality, but it is not second degree inequality or quadratic inequality. Why? Because we don't have x squared. So it is not. What about the third one? Third one is also quadratic inequality. Is it true? No, actually, it is quadratic expression, but as you see here, we don't have inequality symbol. Here we have equal to symbol, so it is not quadratic inequality. It is quadratic equation. What about the fourth one? Fourth one is not quadratic inequality. It is inequality, it's okay, but it is not quadratic because the power is 3, not 2. What about the last one? It is also quadratic inequality because we have inequality symbol and we have x squared as you see. Okay? What about the solution of a quadratic inequality? For example, are the numbers minus 3 and 1 solution of x squared minus 4 greater than 0? Okay, what should we do here? Actually, it is so easy. Just we have to check the numbers. That means we have to insert, we have to substitute the numbers instead of x. Okay, let's substitute and let's check them. Okay, at first, if x is equal to minus 3, then the expression x squared minus 4 greater than 0, then the expression becomes minus 3 squared minus 4 greater than 0. And here 9 minus 4 greater than 0, 5 is greater than 0. It is true, then x minus 3 is solution of this inequality, as you see. What about 1? Okay, now let's check the number 1. The same way again, we have to substitute a number 1 instead of x. Okay, now it is 1 squared minus 4 greater than 0. Now let's check. 1 minus 4 greater than 0. Minus 3 is greater than 0. No, it is not true. Then 1 is not solution of this quadratic inequality. What about all solutions of a quadratic inequality? The same expression again. Can we find all solution of this expression, this quadratic inequality? Okay, logically you may think like that. X squared, if x squared minus 4 is, okay, let's write it. Okay, greater than 0. So x squared is greater than 4. Now you can think like that. Let's take square root of both sides. Then x is greater than 2. It is actually not true, or let's say this expression doesn't represent the all solutions. Why? Actually, the sum of solutions are here. For example, if you write here 3, 4, 5, and the other numbers, actually, or 3.1 anyway, okay, the inequality becomes, the statement becomes true. But it's okay, but they are not all solutions. And how can we get all solutions? Let's think about this one. For example, minus 5, is it solution? Think about this one. Minus 5 squared. Okay, let's check. Minus 5 squared minus 4 greater than 0. Okay, 25 minus 4 greater than 0. And as you see, 21 is greater than 0. It is true. Then minus 5 is also solution. How can we get these all solutions? Okay, actually, we can solve these inequalities. We have this way. We can explain with this way. For example, can we factorize this expression? Exactly. With x minus 2 times x plus 2, it is difference of two squares, as you see. Okay, x plus 2, which is greater than 0. Here we have two chances. What about two chances? The first expression can be plus, and the second expression can be plus also. Sorry, I forgot this. Okay, also plus. Or the first one can be minus, and also the second one can be minus. Dobre? Then if, okay, let's write these systems here. Here we have two systems. The first one, x minus 2 is greater than 0, and x plus 2 is greater than 0. Okay, or the second one, the second option, x minus 2 is less than 0, and also x plus 2 is less than 0. If you solve these systems, you're gonna get, okay, look at here now, x is greater than 2, x is greater than minus 2. What about common solution of this system? So x is just greater than 2. Okay, actually we got this one, but it is not all solution. Or here we have the second one. So x is less than 2, or x is less than minus 2. And here common solution of this system is this one, x is less than minus 2. Then finally, we can see the all solutions. So x is greater than 2, or x is less than minus 2 represents this one represents the all solutions of all real solutions of this inequality. But we're gonna we will not use this way to solve quadratic equations. Let's see the ways in the other next videos. Okay, for now, let's say bye bye, see you.